Just join. I'm waiting for you. Good evening. So today we come to the final part of what do you call it? Tavishi, can you hear me? The first thing.
Yeah.
Okay, that's it. The check is over. Now we are coming to the final part of group 15 today. It is clear. That is a very important part, that is oxyacids of phosphorus. For those preparing for entrance exam, lot of questions are asked on this. So today whole lecture will be devoted to that, and we'll stop because I don't want to start with group 16. That will be the next lecture, which is Friday 6 p.m. Okay. So oxyacids of phosphorus. Oxyacids of phosphorus. See, let us start with first trying, because this is the first time we are going to come across oxyacids. So let us try to understand what is oxyacid. See what happens when you have a central atom M, and if it is attached to OH group. If M is a metal and metal is attached to a hydroxyl group, then these are called as hydroxide. For example, you have NaOH. So NaOH is what it is? Sodium hydroxide. Sodium hydroxide. On the other hand, if you have a non-metal, if you have a non-metal attached to OH, then that is called as oxyacid. Obviously, it is oxyacid because it is acidic in nature. So remember, what are oxyacids? Oxyacids are non-metal which has a OH group. Okay. Now let us understand the general characteristics of oxyacids of phosphorus. That along with the OH group, what does it have? Is this clear? And then only we can proceed with oxyacids. Is clear? So first of all, first question is, in all oxyacids, phosphorus. So in all oxyacids, the first thing is phosphorus is tetrahedrally. Phosphorus is tetrahedrally. So I'm underlining this word, it's very important. Phosphorus is tetrahedrally surrounded by other atoms. By other atoms or groups, like OH could be a group, atom or groups. So that's the first question that we could expect as a multiple choice question. Okay. Then the second one, what happens is, second, all these acids contain, all these oxyacids contain at least, obviously, one OH group and one PO group. At least one P double bond O group and one POH group. So this, because first of all, every oxyacid that we are going to study, the MCQ that they can ask is, in this oxyacid, how many PO groups are there? How many POH groups are there? Because the number of POH groups are going to determine the basicity. Suppose it has 2 POH group, it's going to give 2 H plus ions. So it's a, if it has 1 OH group, it's going to give 1 H plus ion. Is this clear? So that will be monobasic acid. So they ask the basicity of the acid to understand from the structure. So that is how important this statement is. Now the third one, these are general characteristics. The third one is oxyacids with lower oxidation state. Oxyacid with lower oxidation state. Lower oxidation state. What is the criteria for lower oxidation state? Less than plus 5. Is clear? Less than plus 5 oxidation state. What do they do? Okay. In addition, they also in addition have a pH group, pH bond, and or a PP bond, or a PP bond, or a PP bond. Remember one thing, both don't occur together. So you will not have a situation where where there is a molecule which will have a pH bond and which will have a PP bond. So either it will have a pH bond or a PP bond. Is clear? Now what's the importance of that pH bond? The answer is over here. Fourth, all those oxyacids. So all oxyacids having a pH bond, all oxyacids having a pH bond are reducing agent. So obviously they'll give the name. You have to know the structures by heart. So obviously the question will be what? Which is a reducing agent? There will be 4 distractors. So among the 4 distractors, that's the question they'll ask, which is a reducing agent. So look for that structure which has a pH bond. Okay. Then the fifth one, oxyacids having oxidation state plus 3. Oxyacids having oxidation state of phosphorus. Let me be very clear. Of phosphorus plus 3 undergo disproportionation. Now, what do you mean by disproportionation? Disproportionation is also called as what? Self-redox reaction. We have seen this in Cannizzerose reaction in aldehyde ketone chapter. When the same substance, what do you call, undergoes oxidation as well as reduction, then they are called as auto-redox reaction, self-redox reaction, or disproportionation. So those with plus 3, so which will undergo disproportionation is the question we should expect. Is this clear? So what will you do? Knowing the structure, those which have got a plus 3 oxidation state have a tendency to disproportionate. Okay. Now let us look at the first one. I'll finish the first one and then you can take down. Okay. The first one we are talking is hypophosphorus acid. Hypophosphorus acid. This is also called as phosphenic acid. This is also called as phosphenic acid. And the molecular formula is H3PO2. Before I write the structure, somehow, children have, what you call, got this into this mind. As many OA is there, that many H is there, then that many OH groups are there. I told you, all of them have a PO bond. All of them have a PO bond. Only the POH bond, that much H plus ion will get dissociated to give the acidity. So don't get into this mistake that H3POH together will be 2OH, it will be a dibasic acid. This is exactly the question which they ask. Look at the first limitation. They all have a PO bond. If they have a PO bond, so if you look at the structure is you have phosphorus. They have to necessarily have a PO bond. They have to necessarily have a OH bond. They have to have a PO bond and a OH bond. Now the remaining hydrogen. So you can see over here that there is only one OH group. So it is a monobasic acid. That means what? It will give only one H plus ion on dissociation. This is the question which they ask. H3PO2 is, and I don't know. Students always write dibasic acid and get you trouble. Then what happens? The presence of pH bond, what is it going to do? It is going to talk about what? It is a reducing agent. It is a reducing agent. Now let us try to understand what is the oxidation state of phosphorus over here. See, what do we have? PO, oxygen has a charge of -2. Hydrogen has a charge of +1. This has a +1. OH together has a charge of -1. So this will be +1. So because this +2 and this -2 will cancel each other, you have -1. So total molecule to be neutral, phosphorus has to have a charge of +1. So this becomes the third point, that the oxidation state. So this is the third question which they can ask. In H3PO2, the oxidation state of phosphorus is. It is clear. So many of the times in case of oxyacid, try to always find out the oxidation state remembering the structure. Is this clear? Oxidation state is +1. Okay. So this was the first oxyacid. So please take down. I'll give you 2 minutes. Kavishi, you have to tell me that it's finished because today Priya is not there. Na? So just tell me if you have finished. Yeah, take it easy. Okay. Now the next one, I'm keeping these rules as such because we have got this space to utilize. I can relate it very easily. So what happens? The next oxyacid that we are talking about is orthophosphoric acid. The second one we are talking about is orthophosphorus acid. Orthophosphorus acid is also called as, that was phosphenic if you remember, this is also called as phosphonic acid. This is also called as phosphonic acid. We have molecular formula H3PO3. So try to understand what happens over here is, we have phosphorus tetrahedrally placed. There has to be necessarily one pH and one POH. Now what happens is there is still one OH. So what happens is there's one more OH and H. So obviously what can we say first and foremost? There are two OH groups, correct? You can see that there are two OH groups over here, this and this. So what will happen if there are two OH groups? It will be a dibasic acid. It will be a dibasic acid. Then you have a pH, what do you call pH bond. So automatically from the rules that I have put over here, what happens? It is a reducing agent. It is a reducing agent. Then the third one that we can talk about, let us look at the what you call oxidation state. Here oxygen has a charge of -2, +1, -1. So +1, -1 gets cancelled. Phosphorus has an oxidation state of +3. Now here the rule says, oxyacids having a charge of +3 undergo disproportionation. So let us look at the reaction. So what happens? Oxidation state of phosphorus is +3. If oxidation state of phosphorus is +3, it is deemed to undergo what? It is deemed to undergo disproportionation. So what does it do? I mean, you take it as it is, copy down. Okay. Yes, we have got a disproportionation reaction. I had always told you that we are referring this very old book. Okay, so wherever there is a reaction, so its disproportionation reaction is over here. That we have fourth one, 4H3PO3 simply at disproportionates. So at 200 degrees centigrade, it forms P and it forms 3H3PO4. 3H3PO4. So take down this also. That here +3, this will be -3, and that will be how much? Phosphate is PO4 -2. So X minus +6. So that is an example of disproportionation. Please tell me when you take down that. Shresh, finished? Okay. Now the third one. So you can see the multitude of questions that they can ask in this. So the next one that we have is, we have pyrophosphorus acid. Pyrophosphorus acid. So you have pyrophosphorus and you will have pyrophosphoric also. So when you have pyrophosphorus and pyrophosphoric acid, remember one thing, the word pyro should tell you, or it should strike in your head, that you are having what? You are having a POP bond also. Phosphorus, oxygen, phosphorus bond over here. So pyrophosphorus acid will have a molecular formula H4P2O5. Okay. So H4P2O5 will be P double bond O, H, then we have OH, O, P double bond O, H, OH. It is clear. So obviously it has two, what do you call, OH groups. So if it has two OH groups, what happens? If it has two OH group, it is a dibasic acid. It is a dibasic acid. The second one is what? That it has a very important point. It has a POP link. Because up to now we have always talked about PO and POH being compulsory. Some have PH, and pyrophosphorus and pyrophosphoric will have a POP linkage. Okay. The third point, presence of pH, it is a reducing agent. It is a reducing agent. It is clear. Now what happens? Dibasic. Now let us look at A. So you have, when we talk about, see, you have oxygen over here, which is -2. So each one will get -1. This -2 is shared between the two phosphorus. So what happens is, if this phosphorus is getting -1 charge, this is -2, this is +1, and this is -1. So what happens once again over here in pyrophosphorus acid? Phosphorus has an oxidation state of +3. So phosphorus has an oxidation state. So we have oxidation state of phosphorus is +3. It is clear. So when you talk of oxidation state +3, how is it obtained? This also sometimes they have talked. They have said it's obtained by reaction of PCl3 and H3PO3. So let's see if there is some reaction that we have. So you can take down. There is not much. Okay. So this was about pyrophosphorus acid. Then the next one we come to is hypophosphoric acid. See, you have to by heart the structure, so that will help you in understanding the oxidation state. You have to by heart the formula and the structure. So most of your problem, the moment you know these two things, like how I'm correlating, You can quickly work out any MCQ, but this is a minimum necessity. So what we have is, we have the fourth one, that is hypophosphoric acid. So hypophosphoric acid is H4P2O6. It's H4P2O6. If you look at the structure, what do we have? So you have a P, double bond O, double bond O, OH. Just a minute. So P double bond O, P double bond O. Then you have OH, and then you have OH, and then you have OH. It is very important over here. Let's talk about first. We have, it has a P linkage. So hypophosphorus has a PP linkage. That 1 minute, I think this gentleman is. Kamle sahab, I'll call you in half an hour. I'm in a lecture. Of course, live streaming हो रहा है इसके लिए, okay? हाँ, तो PP linkage is the first one. There, how many OH groups are there? 1, 2, 3, 4. So what can we say? It's a tetra, very, very important point. Acid. It's a tetra basic acid. That means it will give 4H plus ion. So very important. Second, third is what? You have to know that it has 4 POH and 2 PO bonds. So 4 POH and 2 PO bond. This is also something which they ask. More important is PP linkage. So what can I say? This is -2, this is -1, and this is -1. So once again, what happens is, we'll have a charge of phosphorus, will have a charge. Each phosphorus will have an oxidation state of +4. So oxidation state of phosphorus is +4. Oxidation state of phosphorus is +4. Okay. Then what else can we talk about? Now here H4. Now this decomposes. A very interesting reaction they have mentioned. So H4P2O6. It decomposes to form H3PO3 and HPO3 to form phosphorus acid and metaphosphoric acid. So this is one more point on heating. That's very important. So it's unstable on heating, it forms this. So please take down. I'm just checking if there's any extra point that we can hit. So this was hypophosphorus phosphoric acid. Then we have ortho. This is the fourth one. So the fifth one is orthophosphoric orthophosphoric acid. Now, what is orthophosphoric acid? It is H3PO4. It is H3. It is H3PO. This is something which we come across in our day-to-day life. Okay. Now, if I talk the structure, it is P double bond O, OH, OH, OH. It's tetrahedrally joined. Okay. So what can I say? There are three OH group. First and foremost, what is it? It's a tribasic acid. It's a tribasic acid. So this is minus oxidation state, minus 1. So 2, 3, 4, 5. So the oxidation state here will be plus 5. So second point is what? Oxidation state of phosphorus. Please remember the formula and the structure. The rest, everything you can work out the way I am doing it. It will be easy for you. Is this clear? And so it has 3 POH bond and 1 PO bond. It has 3 POH bond. This is something is repetition, but then I am writing it because this kind of question is asked. 3 POH bond and 1 P double bond O bond. Okay. Then what do we have? How is it prepared? Now, this is very important. Simple by reaction of phosphorus pentaoxide, P4O10. P2O5 is phosphorus pentaoxide, exists as a dimer. Just dissolve it in water, H2O. And what do you get? You get H3PO4. Now, here you must remember one thing. When it says, I said it's a tribasic acid. The KFC first dissociation. First dissociation. It behaves as a strong acid. That means what? You have H3PO4 forms H plus plus H2PO4 minus. The second one also is a strong. Look at the arrow that I put. H2PO4 minus dissociates to form H plus plus HPO4 minus 2. But then the third dissociation, HPO4 minus 2, it is a weak acid. It forms H plus plus PO4 minus 3. So remember, dissociation of HPO4 minus 2. So for the first two dissociation, it behaves like a strong acid. For the third dissociation, it behaves like a weak acid. This is clear. In fact, I'll tell you very honestly, this is one of the exercise which was given to us in our MSc practical to find out the Ka value of this because if it is dissociating completely, there is no Ka value. But this to this, so using acid-base titration, they were expecting us to find out the Ka value. Of course, we didn't use indicator. We used pH meter to find out the Ka value for this. So this becomes a very important point, right? I mean, the level of experiment increased at postgrad level. That I'm talking about very old days, 1985. So much of the things have changed now. So this is a weak acid. So this dissociation is, so third dissociation, it is behaving like a weak acid. Remotely, they had asked this question in one of the entrance exam. So that is why I'm explaining this. So please take down. Yes. Oh, very good, very good. There is no problem, Priya. We have solved how many? A fifth one. But what I have done today is we are also streaming live in Edumate Plus. Okay. So after the lecture, you just go through the first 15-20 minutes what we have taught. Okay. Today only you can see. Go to our channel Edumate Plus and you can see the streaming. You can ask your friends also to join our streaming service, because we are, as the inspiration came from you only actually when you told me that they had not taught inorganic chemistry. So I said, okay, let us do this, what do you call, service to people. We'll give inorganic chemistry. That is, today I'm completing group 15. Then today is Wednesday. Friday 6 o'clock again there will be a live stream. And in the process we are also understanding the technology. Last time we were streaming by a streaming device called as Prism, but today we are doing by StreamYard. So whichever is good, then we'll subscribe to it. We are also understanding the technology. I think today it will go hopefully good. So you can ask your friends also to join. Now we have 16, 17, 18 left out. You tell me when you are finished. Finished? Yes. Okay. So now this was orthophosphoric acid. Then what do we come? See, last we had done was pyrophosphorus acid. Remember, we had pyrophosphorus acid, POP bond. Here we are doing pyrophosphoric acid. We are talking about pyrophosphoric acid. The formula is H4P2O7. So please remember, I told you, you have to remember the name, the molecular formula, and the structure. All other questions can be answered. Clear? So these are three. Then a lot of questions are asked on this. If you look at your past papers, you realize that a lot of questions have been asked on oxyacid. That's why I didn't finish last. I said we'll take a separate lecture. So pyrophosphoric acid, the structure will be something like this. So you have pyro means automatically it has a POP bond. And then what happens? It is 1 OH, 2 OH, 3 OH, 4 OH. And necessarily, I told you it has to have a PO bond also. So compulsory it will have a PO bond and a OH bond. So what is it that we have? 1, 2, 3, 4. So the first point that we have is it is a tetrabasic acid. It is a tetrabasic acid. The second point that we have is it has 4 POH group. It has 4 POH group and 2 P double bond O group. Okay. Most important point I told you, this is pyrophosphorus and pyrophosphoric. These are the only two oxyacids which has a POP linkage. So remember those oxyacids with PP and a POP linkage. This is something which this kind of questions are asked in entrance exam. So it has a POP linkage, pyrophosphorus and pyrophosphoric acid. About oxidation state, see this is a total has a -2. So each is sharing -1. So -1, -2, -1, -1. Okay. So what will we have? 2, 3, 4, 5. So here phosphorus will have, each phosphorus will have an oxidation state of, this is a slight revision of how state also. I mean, this is your 11th standard redox reaction. So here the oxidation state. So the fourth point is oxidation state. Oxidation state of phosphorus is +5. Of phosphorus is +5. So now what happens is the very interesting thing that they have said. Okay. Yeah. See, I'll write the reaction above because below we may not have space. See, it is something like this. You have 2H3PO4. When you add at the center is this H4P2O7. So when you remove water, you will get H4H3PO4. And when you add water, you will get H4P2O7. Is this clear? So this is one thing. And then what happens is, if you further heat it, so if you further heat it minus H2O, so minus H2O, you got this. You heat this further, you get 2HPO3. So this will summarize all that. You further heat it, remove one more water molecule, you get P2, P2O5. Now the reverse is P2O5, you add water, you'll get 2HPO3. 2HPO3, you add water. What happens? You will get H4P2O7. That, this is it. That you add water, you will get H3PO4. It's a very interesting sequence that they have given. So, because a question like this this is metaphosphoric acid. So anhydride of metaphosphoric acid is P2O5. Now anhydride of the pyrophosphoric acid is metaphosphoric acid. Anhydride of orthophosphoric acid is pyrophosphoric acid. So that is the question which they will try to ask. So that is why this equation is very important. Please take down. So this is metaphosphoric acid, phosphorus pentoxide. If you are not very clear, okay. So this is in group 15. Okay. Okay. Now the next one, last one is you have polymetaphosphoric acid. So you have polymetaphosphoric acid. So as the word poly itself tells you that there are many phosphoric acid groups joined together. Basically, it's a polymer of metaphosphoric acid, which is H3PO3. Now, what happens is, how many does it join? 1, 2, 3. So you have P double bond O, correct? OH, and then you have POH. So then what will happen is, then this will have an oxygen linkage like this. Again, you will have P OH over here, P double bond O, then oxygen linkage, then P double bond O, there will be OH over here and oxygen. So this tells you what are we knowing? First and foremost, so minus 1 is minus 5. So each oxygen has a, so phosphorus has oxidation state of +5. Okay, then what can you say? Very important, huh? 2 POP bond. Okay, then how many OH group? 1, 2, 3. 3 POH group. And how many PO? 3 P double bond O group. So this is how they are. Then, very important point, very important point. It is also called as glacial phosphoric acid. It is also called as glacial phosphoric acid. So this sums up our today's work, that is discussion on oxyacids of phosphorus. You please take down this and then you can leave the portal. For those who are watching my live stream, the next lecture will be on Friday. Okay, at 6 p.m. I will be, you can go to the channel Edumate Plus, and we will be starting with a new chapter, that is group 16, oxygen, sulfur, selenium, tellurium, polonium. Okay.